Hey guys, welcome to CJ Studios, and today I'm here to bring to you one more class about programming concepts using blueprints in Unreal Engine. In the last class, we learned about data types and variables, and today we are going deeper in variables and learn about operators and control flow. If you have missed the last class, I will put the link so you can watch it right now and then come back to this video. To begin with, what are operators? The operators are symbols or keywords that manipulate the information they retrieve from the variables, and based on that operation we can receive new data. We have three main operators that I will show to you. The first one is arithmetic, that are math operations like adding, subtracting, multiplying, dividing, and many others. Let's make an example. 1 plus 1, 2. The plus here is the operation for addition. Another example is 2 times 2 equals 4. The operator here is the multiplication, and many other examples. The next operators are relational operators. The relational operators means comparisons like equal, different. Remember, all that symbols I'm writing here are the symbols used in programming language and are also the symbols that you will use to find them in Engine. I will show you, but let's keep going. Other examples are less than, greater than, greater or equal, less or equals. And the last one are the logical operators that are used to make comparisons with using true-false values like and, or, not, and others that we will see further. One important thing is to notice that both relational and logical returns Boolean values that are true or false, but they are different. Like the relational makes comparisons like 1 equals 1, so it's true. And the logical uses two Boolean and compare them. Like, let's assume we have A and B, and both are Boolean, and we have A and B, A or B, not A and not B. So if A is true and B is true also, A and B are both true, so the result of A and B will be also true. Here, if we have A or B, both are true, so we also have true. Not A, it's the negation of true, so the negation of true is false. And the same for B. But let's assume that we have false in both. So A and B are false, because neither A neither B are true, so A and B are false. A or B is also false because none of them is true. Not A is true and not B is true also. But let's have another example where A is true but B is false. A and B is false because despite of A being true, B is false, and both are not the same true value. So the result is false. A or B, otherwise, can be true. And why? Because if n of these values is true, using the OR operator, we have the true result. And here, not A is false and not B is true. I'm here with the project of the last class open, the hello world and all the things we've done. So I'll just delete those things. I'll get just this print here and delete these variables. I created two variables to start with arithmetic. So I used A and B, and I choose to use floats because, as we have seen in the last class, the values can be decimal, can be not whole numbers, and the results will be better. Like if we divide one number by another and it's like half or 0.25, we can't have it in integer. So we have more operations to do here with floats, but the main ones like plus operation and subtraction, multiplying are also available for integer, but floats are more complete. So let's use them, A and B. So the first one I want to show you is the add-in. You can search here add or just type a plus, and here we have the addition operator. Like here you can see the description, addition A plus B, and here we set the values. Let's compile just to set that, like 1 plus 1. Let's compile. Here we have 2. So let's see the other operators that we have. We just hold control, left control to unplug this. Subtract, multiply, divide, power. That returns just the remainder of the divisions. So I will put it here. Let me think more. Square. So I've added the most important ones. We have seen A plus B. Let's see. A minus B. Remember, A is 1, B is 1. So we have 0. When we multiply, I will just change the value like 2 and 2. I think it's better. Here we have 4. Division. I will choose 4 and 2. Now compile. 4 divided by 2, we have 2. So, showing how it works, like we have the rest of the division. If I divide 4 by 2, we shouldn't have 0. Let's check. Exactly. But imagine if I divide 3 by 2. Like we did back in school, we have 3 divided by 2. Here. 1 multiplied by 2, we have 2. And here we have 1. So that's the result, and that's the remainder. Here A is 3, B is 2. Let's file and run. We have 1. like we did in the board. So let's keep moving. Here we have power. We use the base and the exponent, like 3. We will add these values here. Going back to the board, we know that 3 square is the same as 3 times 3 2 times, like if it was 3 cube, it will be 3 3 and 3 3. It would be 3 times 3 times 3 and keep going. So let's go back. So we compile here and let's run. Here we have 9. That's 3 square. Let's try 3 cube. 27 and 4. 81. Okay. And the last one, it uses one number, just one. Let's use A. And here we have the square root. Like, square root is, let's see, 4. The square root of 4 is the same as 4 at the power of 1 divided by 2, and it's the same of 2. So we multiply here the exponents. We have 2. That's that. There are many ways to do that, like you automatically know that 4 square root is 2, or you could do like this. This is the same. And so we go. Let's put a value here of 4, like we did that. We have 2. And one thing that I didn't find here in engine, but it's very useful, it's the root, like cube root or n number. So as an exercise, let's do a function. I will explain you more how functions work, but let's do something like this power function, but now with roots. We will call it roots, and as we see here, we'll do the same thing, but we will call this one root. So let's put here input and base root. Okay. So to return the root, I'll show you when we have number, the root of this number is, let's use y. This is the same of x at the power of 1. Knowing this, let's go back to the engine and use here power. Here we use the base. The root will be 1. We will divide 1 by the root and use as exponent. We click here and output. We use result. But just return. Okay. Going back here, we have this root function. One thing is to check this option. I will explain more of how this works, but it will be like the other one. And let's test. We have the base A at the root B. Let's use 81 at root 4. And here we have 3. It should work with any number, like we have 9, the square root, it's the same thing. We have 27, and the cubic root is 3. So that's a good exercise to implement the things we learned here. If you need to have the root that's not just the square root, you can use this node now. But let's keep going. To the relational operators, we will still use the floats. As we have seen, we have equal. That here you can see all the symbols. You can both write the name of it or these symbols. They do the same thing. Let's put all. Here we have. Let's use the first one and drag here. Okay. Let's compare A to B. A is 0, B is 0. So they should be equal. And here we have true. If we have a different value, it won't be true. So let's go to the next. This one is exactly the opposite of the other. Like if we have different numbers, it will be true. Here, let's put equal numbers, 1 and 1. And here we have false. The next one, greater than, we have A. Let's set a value of 2 and B a value of 1. Let's just use 1. A is greater than B, so we have true. But if we have 0, that's less than, we have false. Here we have the opposite, less than, like 0 is less than 1, but 2 is not less than 1. Here, greater or equal, A is 2, B is 1. If A is greater or A is equal to B, we will have true. Let's check. That's true because A is greater than B, 2 and 1. But if we have 1, it's also true. And the same thing for less than. And the same two, less or equal. They're the same now, 1 and 1. And let's put 0. And it's still true because A0 is less than 1. And let's put just 2 to check it's false. Okay. And to finish this part about the operators, we have the logical operators. Like here, I've talked about these three, and, or, and not, but I will explain these three others. So I will just use these checks to be more clear, but it's the same as using this, like checked means true, unchecked means false. So let's start. Like I said, when we have the AND and both are false, we return false. When just one is true, we still have false because we need them both to be true. Okay. The OR operator means if one or the other value is true, it will be true. But if both of them are false, it will return false. Let's see. We have both true. We return true. If we have just one of them true, we will still have true. But if we have none of them true, it is false. The NOT is, like I said, the negation of the value we set here. So it's false now. If we compile and run, we have true. If we have true, it will return false. These other three, let's see what they mean. These two first are very similar, but they have their particularities. Let's check it. What chore means is basically just A or just B. Let's see in practical how it works. If both are false, we have false. If just A is true, we have true. If just B is true, we also have true. But if both are true, we have false, because we have just A or just B. That's what sure means. So let's go to the next one. Nor is very similar, but it's not the same thing. The difference here is that nor means we have not A and not B. Like if both are false, we have true. But if any of them is true, we have false. No matter which one is. So basically, it's the same as a not or. So the last one is the NAND. That, like the NOR, it means not and. Like, if we have both, it will return false. If we have both false, we return true. Or if we have n of 10 true, we return true. It's the same of not and. Now let's move to the control flow. The control flow defines how the instructions we will program will run, like the order, the conditions of how they will execute. And here we have two main structures that we will see now. The first flow structure I will talk here is the conditional. Basically, we state conditions that will make our logic be executed if the condition is attended. In code, we use if, and here we put the condition. That condition can be true or false, and here we have what our code do something. And we also have the else, that if this condition is false, this part will be executed. Let's see how it works in engine. Instead of having if, we have the branch. But also if you search for if, it will direct you to the branch. Here we have a condition that's true or false, and we have two ways of execute or instructions. If the condition is true, we have one. If the condition is false, we have another. So let's create a condition. I will first set a variable here called live points. It's like the health of the character, and we'll let 0 at this moment. And let's go here and use a condition. If it's greater than 0, we drag to the condition. I will duplicate this print because we will use 2. If this condition is true, we are going to print you are alive. But if it's false, we will put here you are dead. So let's compile and run. You are dead. Because the default value we set here was 0, but let's set to 100. You are alive. Like n number greater than 0, let's say that you are alive. That's important to store information like this, like this player alive. We can set you here Or even in a simpler way, we can set it directly, like here, and use directly this condition, and then use the branch here. Ask to the variable, is player alive? If true, you are alive. If false, you are dead. Let's see. You are alive. Like I have 1 point. If I set to 0, you are dead. We have another special kind of conditional. That's the switch that receives a variable. Let's assume that variable is an integer. In the switch, we have the default case. That's what the code will execute if none of the conditions are met. Do nothing. So it's an integer. And here we can put case 0 A, case 1 B. And we define as many as we need to define, but let's see this in practical. In the last class, we created this enumeration called if-fruits, but I will create another one to use as example, enumeration, and I will call it gates. That are the different gates when the character would be moving, like walking, jog, and sprint. Okay, let's go back to the blueprint, and I will put a condition here. Let's call it gate, and we'll just cut here and put here switch on gates. Here we drag to get the value, and as you can see, we have 3 options of execution based on the value of gate. We could also have a switch based on different integer, like I said, switch on NAND, and here you configure different values, like if you have a small set of values and want to execute different things depending of how this value is set, you can use this, but I prefer to use the enumeration. And let's do the code. I will just copy here and paste. Character is walking. Character is yoga. Character is sprinting. Let's run. Character is walking. That's what was set here. If we change to jog, compile, character is jogging. If I set to sprint, character is sprinting. So I will put here just as an example. I will go deeper in this subject later, but I want you to know this is shift. I will use it to set the gate value. I have this detect if the left shift is pressed. So I will have a default state that is jogging. There is not going too slow, but not going too fast too. And when we press shift, I want to set it to sprint. And when I release it, I want to set it to jog again. And then we are put this here. We can have more than one execution. Let's go like when I press shift, character is sprinting. When I release, character is jogging. Let me just put less time on the sprints. 1 second is fine. Sprinting, jogging, sprinting, jogging. So to implement the walking tool, there are many ways to do this. That's how I usually do this. I will show you. Left control. I like to put it in left control. The basic logic would be sprint, walking, just switching this, and going here also. Now when I press control, it's walking. When I release, it's jogging. But we have a problem here. When you press both, it say both. We just want to set one. We can put a condition here that's press it. Like here. We get the current gate. If we press shift to run and we are jogging, we should sprint. If we are sprinting, we do nothing. If we are walking, we will just jog. And the same here. When we press left control, if we are walking, we do nothing. If we are jogging, we start walking. And if we are sprinting, we start jogging. And 2 more conditions to not get too much complicated. Let's just adjust here. So we have these 3 conditions here too. If left shift is pressed, we certainly will not be walking. We can be jog or sprinting. But if we are jogging, it means left control is also being pressed. So if we release the shift, we should go to walking. And if we are sprinting, normally we just go to jog. And here, the same logic. Like we press the left control and release it. If we were walking, it means we were not pressing the left shift, so we just go back to jog. If we were jogging, it means we were pressing also the left shift, so we go here to sprint. And that looks a bit complicated, but it's not. Let's just try it. If we press shift, sprint, release jog, control is walking. So if, like here, we are walking and then press shift, now we are jogging. And when we press shift and start pressing control, we are jogging. But we release control, we are sprinting again. And that's the exercise about these conditions. I hope it wasn't very complicated. If it was, I'm really sorry, but this is very useful for your games. And let's move. The other flow structure that we will see today is the loops. And what are the loops? They are codes that repeat. And for now, we will see two different kinds that are the while condition. While this condition is true, we do something. And we also have the for structure that have three statements. The first one is the iterator that we will set to 0 in this example. The second one is the condition itself, and as in for we use iterator, the condition can be like I less than 5. And finally, what we will do to this iterator every loop executed. This means I will add 1 to the value of I. And here, let's put something like print I. So let's just imagine how it would work. In the first loop, I is 0, this condition is true, and we will set I to I plus 1. That's 1. Okay, we get this value here, I equals 1. It is still less than 5, so we have true. So we will set to 2, and we keep going until the value of I is equal 5. And now let's use again the life points we created. I will just reorder it to the end. The first thing I will do is to create a variable called max life points. Drag it here and use the last operator and use this as a condition. I'll put it here and drag the loop body to print. That loop is what will be executed during each loop. Let's put here get life points and type this. This is the same idea I show you in the drawings. It adds 1 to the value. Okay, and let's print. Let's put a long time to see it for too long. Nice. So what this loop does, while the life points are less than the max life points, we will add 1 life point. So the character is regenerating his life points, and we will see the progress here. And here, with this completed, I will put another print string and say life fully restored. Remembering that the debugging executes from bottom to the top of the screen. So let's see how it works. One last thing is to set our max life points. Let's set it to 25. Okay, and we start with, let's put 1 just to not be that. So let's see. And here we have our life points going up like 2, 3, 4, 5, 6, 7, 8, and keep going. And finally the message life fully restored. The other example, it's the loop body. It uses first index, that's the same as the iterator I've shown you in the drawings. I've already set the same value, so when this index it's equal to this value, it will stop. Let's just copy a print and print the index that they done. And let's see, as you can see, it goes from 0, 1, 2, 3, 4, 5, but we can set n number here and we will do the loop these times. Okay guys, that's everything I wanted to show you in this class. Hope you understand everything. If you don't, you can go back and watch again, or just drop your question here and I will answer you as soon as possible. And if you liked that video, hit the like button. If you are not subscribed yet, subscribe to the channel. Hope you like it. I hope you are doing well and see you in the next video.